Hello students, welcome to the lab session, today's lab. Today we'll be discussing some exercises. I'll explain the exercises as part of your PPSUC Lab. And, one of you are requested to practice these programs at home, then write your observation as well as record. So let us start with the first exercise. Exercise 1 has some number of programs. The first program in exercise 1 is 1.1. The program is write a C program to print a black F using the hash symbols. That means we want to display an F symbol with the help of only F's like this. And it is also given that F has a height of 6 characters, that is 6 hash characters as height. 1, 3, 4, 5, 6. Then 5 and 4 characters as width. So here we have 5 characters width, and here we have 4 characters width. So as it is, we are going to display the number of hash symbols with the help of printf statement. Okay, so for that, we'll include the stdio.h file here. Then start the main function. The first row contains how many hash symbols? There are 5 hash symbols. So just use a printf statement to display 5 hash symbols, and then to move to the next line, use a slash and here. And in the second line, there is only 1 hash symbol. So printf single hash symbol followed by slash n to move to the next line. And then the third line also contains a single hash symbol. The printf hash to move to the next line, it is slash n. And the fourth line now contains 4 hash symbols. So we'll make use of printf 4 hash symbols followed by slash n. And fifth one and sixth one has single hash symbols. So printf hash slash n, printf hash slash n. Okay, because main is expecting a return value, return some 0 to indicate the successful execution of the program. Okay, so after executing this program, we should get this output. Okay, so the F symbol, which is made up of only hash symbols. This is 1.1 program from exercise 1. Let us move on to the next program. This is 1.2. Read that 1.2 exercise. It is write a C program to compute the perimeter and area of a rectangle with a height of 7 inches and width of 5 inches. Okay. So what we need to read from the user? We are going to read the height and width from the user, and using this height and width, we can calculate area is equals to height into width, and perimeter is equals to 2 into height plus width. Using these two formulas, we can calculate area and perimeter. And then we will display the message printf area of rectangle is percentile f comma area, and area of perimeter of rectangle is percentile f comma perimeter. Okay, right. So because these are all the variables utilized here, you need to declare the variables which are used in your program. Float, height, width, area, parameter. So 4 variables are used in the program. All of them must be declared properly. So if you look at the output, the first message that gets displayed to the user is enter the height and width of rectangle. So it is asking here, it's not length, it is height. Enter the height and width of the rectangle. User will enter some values. Let us say it is 7 and 5 because it is given as height is 7 inches and width is 5 inches. So I am giving the same two values, 7 and 5. And the area of rectangle becomes 7 into 5, that is 35 square inches. It is displayed here, printf area of rectangle 35 square inches, the message to be displayed, and perimeter of rectangle is 24 inches. So that is the message you are going to get. Okay. So this is a simple program which we already practiced in our classroom session also. So you can refer to that program again. This is your 1.2 exercise. And 1.3 from exercise 1 is write a C program to display multiple variables. This is the simplest program which declares some variables here. You can declare any number of variables based on the fundamental data types and qualifiers, and you can use any data type in C language. So here a integer variable I is declared, a short int variable si is declared, a long int variable li is declared, float f, double d, long double ld, char c. A total of 7 variables were declared in this program. And then this part reads all the variables by asking the user enter a character and stored into C. Enter int, short int, long int. We are using percentile d for int, percentile hd for short int, percentile ld for long int, and store the values into corresponding variables. I is integer variable, si is short int variable, and li is long integer variable. We declare them here. Okay, and then we are asking enter float, double, and long double values. For float, it is percentile f. For double, it is percentile lf, and for long double, it is percentile capital LF. This small LF means that it is double. Capital LF means that it is long double. And the corresponding values are stored into F, D, and F. So this particular statements are used for reading the values. Okay. So we declare the variables here. This part is declaration part. Okay, and this is reading, and then we display the values here. So we display the values here. This is going to be displaying the values. So given integer value is percentile d comma I. Given short int is percentile hd comma si. So just use the variable names to display the corresponding values. It's a simple program where we declare, read, and display the values. You can use any number of variables. Okay, that is of your choice. So the output is now corresponding the messages will be displayed in this program. First, it asks to enter the integer, short int, and long int values, and then float, double, and long double values. Assume that these are the values given by the user, and later it asks enter a character. So user is giving some character here. Then it is displaying the given values, given int value, given short int value, and so on. You need to compare these values with the given values. Okay, so it is displaying fine. All the values are same as displayed values. Okay, this is about 1.3. So in exercise 1, we have 3 programs: 1.1, 1.2, and 1.3. Simple programs there. Just practice them. Use Turbo C editor for executing these programs, and then write your outputs into observation as well as record. Okay, I hope you got the printout of those record sheets. So all of you write down, finish up this record work and observation work as early as possible. This is exercise 2. In exercise 2 also we have multiple programs. The first program is 2.1. 2.1 is write a C program to calculate the distance between 2 points. So you will be given 2 points, let us say x1 comma y1 and x2 comma y2, and you need to calculate the distance between the two points by using the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is the formula for calculating distance between 2 points. Okay. So first what we need to do is declare that variables x1, y1 and x2, y2 to read the points, and then use a variable list to calculate the distance between given 2 points. Okay. So as a first step, ask the user to enter the first point x1, comma y1 and store them into the corresponding locations ampersand x1, ampersand y1. And then ask the user to enter the second point x2, comma y2 and store them using ampersand x2, ampersand y2 into the respective locations. Okay, so now we have 2 points x1, y1 and x2, y2. We are ready to calculate the distance. Distance is equal to square root of for using this square root function, you need to include this math.h here. Otherwise, this sqrt will not work. Okay, so sqrt is a function which returns the square root of a given value. The square root of this is the entire formula. If you read this formula properly, it is x2 minus x1 whole square. For square, we will use x2 minus x1 into x2 minus x1. Therefore, it becomes x2 minus x1 whole square plus y2 minus y1 into y2 minus y1. That is going to be y2 minus y1 whole square. Okay. So this entire part comes as x2 minus x1 whole square plus y2 minus y1 whole square. And for this value, we are applying a square root function. Then it becomes square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So the result of this formula will be stored into dist. Okay, so dist stores the result, and then we are displaying the value of the distance between 2 points as printf distance between 2 points is percentile f comma. The result is already available in this, therefore we display it here. Okay, so this is how it executes. Let us say the first point is 5, comma 9, and the second point is 4, comma 8. The distance will be calculated as 5.656854. So I don't think this is the correct answer. Please, all of you, do it in your own and write down the distance here. Okay, so it's just a answer which is randomly given over here. So to show the output. Okay, so please give these 2 points as input and then calculate the output. Write it over here. Okay, in your observation and record. So this is 2.1 program. At 2.2, in exercise 2, we have the second program, 2.2, is write a C program that accepts 4 integers PQRS from the user, where R and S are positive and P is even number. Okay, so there are some constraints given over here. The input should be given like this. If Q is greater than R, S is greater than P, and if the sum of R and S is greater than the sum of P and Q, print correct value. So if all these conditions are met, we are going to print correct values, otherwise print wrong values. Okay, so this program is asking to read 4 integer values PQRS, and then based on this condition, either we are going to display correct values or we are going to display wrong values. Okay, so let us start the program. You require 4 integer variables. So int PQRS, because the names are also given. PQRS are declared here as integer variables. Then I'm asking the user to enter PQRS values because there are 4 values that will be entered by the user. I'm using scanf percentile d, percentile d, percentile d, percentile d, comma, ampersand P, ampersand Q, ampersand R, ampersand S to store the 4 values. Now PQRS contains values. So what are the restrictions given over here? R and S must be positive. So how do you decide that R and S are positive? If R is greater than 0 and S is greater than 0, we can say R and S are positive. And what is the next condition? P is even. Okay. So the next condition is P is even. You can see it here. P is even. To specify that P is even, to check that P is even, we will use this condition. P percentile to divide P by 2, and if the remainder is equals to 0, then we can say that P is even. Okay, so first 3 conditions, and there are more conditions. And what is the next condition? If Q is greater than R and S, Q is greater than R and S is greater than P. What is the first condition? Q is greater than R, and second condition is S is greater than P. Okay, and if the sum of R and S is greater than sum of P and Q, that means sum of R and S is R plus S is greater than sum of P and Q, that is P plus Q. If all these conditions are met, what is the message that we are going to display? It is correct values. So we display the message as correct values if all these conditions are met, because we use logical and operator to combine these conditions. This becomes true only if all the conditions we mentioned here becomes true. Okay, then it displays correct values. Otherwise, in else part, we will display printf wrong values. So either this message or this message will be printed. Okay. Suppose if PQRS are given 4, 8, 2, 13, the message gets his correct values because they satisfy all the conditions. And for example, if you give 9, 3, 1, 45 as input values, 4 values, it gives the answer as wrong values because it will not satisfy condition. For example, say the third value. What is that condition? E is even. E is even is not satisfied. 9 is not even, therefore this becomes false. That is, program displays a message wrong values. Okay. So this is a simple program which uses if and else to check the conditions. Okay, and also in if part there are multiple conditions check over. And while writing the output for this program, you give these two outputs to verify whether it is working properly for correct values and wrong values also. Okay, that is exercise 2.2. That's all. In exercise 2, we have only two problems: exercise 2.1 and exercise 2.2. We'll discuss one more exercise, exercise 3. 3.1 is write a C program to convert a string into a long integer. So we have a function, a predefined function named as A to L to convert any given ASCII string into a long integer. Okay, so we can directly use this A to L function and pass the corresponding string as parameter, which returns the long integer, equivalent long integer into the program. Okay, so for that, we declare a variable as L for storing the long integer returned by the function, and for storing string, you declare a character array char str of 30, and then ask the user to enter the string. Enter a string using printf and store it into str by using scanf %s. Once you got the string from user, just pass it as parameter to A2L function. This is available in standard lib.h. So you must include this header file as part of your program. Okay. So once you call that function, the equivalent integer, long integer, will be returned by the function, which will be stored into L. Then we can display the message printf string to long integer is %ld, comma L, because the result is available in L. Right. So for example, if I enter a string 1, 2, 3, 4, 5, 6, 7, 8, 9, this will be stored into the character array as a string, and once it is converted, it comes out as a number 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is the first program for converting a string into long integer 3. Now this is the second program 3.2. 3.2. What is this program? Write a program in C which is a menu-driven program to compute the area of various geometrical shapes. So it is not mentioned here what are the geometrical shapes that we are going to use. Therefore, you can pick any 2 or 3 geometrical shapes here. In this program, we used circle, rectangle, and triangle for calculating area. Okay. So because it is mentioned as menu-driven program, you should use a switch case as well as to repeat the program execution, make use of a do while. So, okay. So in do, we'll display the choices for the user using printf. Okay. So let us understand it from this point. We'll come back over here later. This is just a declaration part based on what variables are required into our program. right? So the program begins with a display of menu. What is the menu here? Printf one is area of circle slash n, that means it goes to next line. The second item in menu is area of rectangle, and then third item in menu is area of triangle, and fourth item is exit. So we are going to repeat this loop because it is a do while loop. We are going to repeat this loop until user selects this fourth choice, exit. Okay, and then I am asking the user to enter a choice. He needs to enter either 1 or 2 or 3 or 4 based on his requirement, and read it into ampersand choice here. Okay, so now choice stores either 1 or 2 or 3 or 4 based on user enter the value, and the value decides which operation is going to be done. If user enters 1, we are going to perform area of circle. If user enters 2, then we need to calculate area of rectangle. If user enters 3, then we need to calculate area of triangle. If user enters 4, then stop the execution of the program and go out of it. Okay, these are the possible choices. So let us make use of a switch statement, switch of choice. If choice is 1, that means if user enters 1, then case 1 will be executed. What is case 1? He wants to find the area of circle. Therefore, to find the area of circle, you need radius. So ask the user to enter radius in case 1 and store it into ampersand radius. Once radius is available, calculate it using the formula area is equals to pi r square. That means 3.14 into radius into radius. This is same as pi r square formula. Pi means 3.14, r into r means radius into radius. Now the answer is available in area variable and displayed. Printf area of circle is percentile f comma area. The value gets displayed. So once the case 1 is executed successfully using break statement, you go out of switch. Okay. For example, if the user enters the second option, what is second option? Second option is area of rectangle. Therefore, in case 2, we will write the code for handling area of rectangle. To calculate area of rectangle, you need length and width of the rectangle. Therefore, ask the user to enter length and width. Store them into two variables using scanf, percentile f, comma, percent length, comma, percent width. Okay. Then calculate area is equals to length into width. So once area is calculated, display it using printf. Area of rectangle is percentile f, comma, area. Okay. When we do this, if the user enters the choice case 2. If user enters choice 3, it means he wants to calculate area of triangle. So in case 3, we will handle the code for calculating area of triangle. So how do you calculate area of triangle? The formula is 1 by 2 into base into height. So ask the user to enter base into height. Store them into two variables, base and height, using scanf, percentile f, ampersand base, comma, ampersand height. Then calculate the area is equals to half into base into height, or you can write it as base into height by 2. Okay, so once area is calculated, display it using printf statement. Area of triangle is percentile f, comma, area. Okay, so if the option is 3, we will do this. And if the user enters fourth option, that means you don't want to calculate area of any of the geometrical shape given. You want to go out of the program. Therefore, in case 4, we'll write code for exiting the program execution. So look at that exit of 0. Exit of 0 is used for going out of your. Okay. So to execute this exit of 0, some compilers asks for the header file also. In case if your compiler is asking for header file missing, then include process.h. Okay, so you may need process.h to execute your exit of 0. So maybe if your compiler asks about the corresponding header file, use this hash into process.h for executing that exit of 0. Okay, so this may be required. Not every compiler asks for this. If your compiler asks, then you use this. So that's all. Exit of 0. This 0 value 0 specifies the operating system that the program is successfully executed and it is terminating properly. So 0 indicates the corresponding operating system that program is successfully terminated. Okay. And then you can see it here while 1. 1 means infinite loop, that is, it is always true, or you can write it as while true. Okay, so this means do while is an infinite loop. Do while is a infinite loop because we mentioned it as 1. Any non-zero value will be treated as true here. Okay, so while true means the loop is always true, so you are always going back for execution until user forcefully goes out of the program using fourth choice, case 4. Case 4 executes exit, which forcefully stops your program and goes out of the program execution. So until this is done, the program always asks about, shows the menu to user, and then based on the choice entered by the user, it executes the corresponding program. Okay. So this is how it executes. It shows the menu. 4 options will be displayed first, and then asks about enter your choice. Based on the choice, it displays the corresponding message. Okay, so if choice 1 is displayed, selected by the user, then it will ask the user to enter the radius and calculates the area and displays the area of the corresponding circle. Okay, similarly, if the user selects another choice, it continues like this until user selects the choice 4. It's an infinite loop, so it keeps on asks the user to enter the choice until user selects the 4th option. Okay. So this is 3.2. And in exercise 3, we have 3.3 also. This program is used for calculating factorial of a given number. So write a C program to calculate the factorial of a given number. This is our third program. Okay. Right. We can calculate the factorial of a given number for an integer only. Therefore, I'm declaring the variable num as integer and ask the user to enter a number, store it into num. So once the number is available, we can calculate the factorial by using the formula 1 into 2 into 3 into 4 into so on up to n. Okay, so for multiplying, we will make use of a for loop that begins at 1. Okay, so the initial value is 1 and repeats up to number, the given number. That means we'll start multiplying with 1 and we will continue the multiplication up to I becomes num. Okay, so for repeating, so I will use this loop I is equal to 1, I less than or equal to num, I plus plus. And what we do is initially the result of factorial is initialized as 1 because the minimum factorial value is 1. So we know this. Even 0 factorial or a negative number, even if a negative number is given, the factorial value is going to be 1. Because the minimum factorial is 1, it is initialized to 1. And then we multiply it with every number from 1 to number. Okay. And we store the result back into fact. That means if I is equal to 1, initially it multiplies 1 into 1 because fact is 1 and stores the result 1 into fact. And in second iteration, it goes back here, I plus plus. Now I becomes 2. 2 less than or equals to num. Let us say number is 5. Now I want to calculate 5 factorial. So 2 is less than or equal to num. And again, fact is equal to, fact is 1 into 2. Now the result is 2. 2 is stored into fact. Okay. So let me show the iterations over here. So initially, fact is initialized to 1. Okay, here. And then I'm asking enter a number and user is entering some number. Let us say num is entered by the user. Assume that the number is 5. The user entered 5. That means he wants to calculate 5 factorial. The result should be 1.2. Okay. So initially fact is 1. Number entered is 5. Now let us begin with this for loop. initially I is equals to 1. Okay, so it is starting with value 1, I is equal to 1. Since 1 is less than or equals to number, what is number here? Number is 5. 1 is less than or equal to 5. The control goes inside. Calculate this fact is equal to fact into I. So what is fact? It is 1. What is I? It is 1. 1 into 1 is calculated. The result is 1. It is again stored in fact. So again, the fact contains 1 after performing the first iteration. From here, the control goes back to I plus plus. Okay. That means I value is incremented by 1. That means now it becomes 2. Okay. Again, it goes to the condition checking from here to here. Okay. Now it is 2. I value is 2. 2 is less than or equal to 5. Yes, it is. Condition is satisfied. Therefore, again, this is calculated. First, this RHS value is calculated. That is, fact into I is calculated. And then the result is stored into fact. You need to understand that. Okay. So, what is fact into I? It is 1 into 2. And the result is copied to fact. So, 1 into 2 is 2. The result is now copied to fact. Now, fact contains 2. Okay. Then it goes back to I plus plus. That means I value is now 3. Okay, it is incremented. Now the value of I is 3. It is again goes back to condition checking. Now 3 is less than or equal to 5. It checks. Yet yes, the condition is met. Therefore, it goes inside. Again, it calculates this fact is equal to fact into I. Means it performs this fact into I and stores the result into fact. So what is fact now? It is 2. And what is I? It is 3. 2 into 3 is calculated. That is 6. 6 is stored into fact. Okay. Now 6 is stored into fact. Again, it goes back to I plus plus. Now I plus plus becomes 4. Okay. Now it is 4. And 4 less than or equal to 5. Yes, it is satisfied. 4 less than or equal to 5 is satisfied. Again, it enters inside. Fact into I is calculated. That is 6 into 4, which means 24. 24 is now stored into fact. So the result of fact is 24. Okay. Again, from here it goes to I plus plus. Now the value of I is 5. Okay. Again, the condition is checked here. 5 less than or equal to 5. Yes. 5 is equal to 5 is satisfied. So it goes inside. Again, it is calculated as fact into I. Fact into I is 24 into 5, which means it is 120. 120 is stored into fact. So the result in fact is 120. It is 120. Right. Now it goes back to I plus plus. Now the value of I is 6. Again, it goes to condition testing. 6 less than or equal to 5 is not true. It is failed. So once this condition is failed, it comes out of the for loop and goes to the next statement immediately present after for loop. Okay. So what is it here? It is displaying the message using printf. Factorial of percentile d is percentile d. So in first percentile d, num is displayed. What is num here? It is 5. Therefore, factorial of 5 is percentile d. Here it is displaying the value of fact. What is the value of fact? Is 120. Okay. So fact, enter a number. We entered 5. Factorial of 5 is 120. It is displayed. Okay. So that is how it executes. We used a for loop here to calculate the factorial of a given. Okay. So I hope you understood this. Practice this program. This is an important program for your examination point of view also. Okay. So this is exercise 3.3. So that's all for today. We have discussed about 3 exercises. Okay. Let us complete the 4th exercise also. Okay, let us go through this 4th exercise also. Exercise 4 is 4.1. Is asking to write a program in C to display the n terms of even natural number and their sum. So we are going to consider only natural numbers and calculate their sum. Okay, so for that, we will ask the user to enter how many terms he want, how many terms of even natural numbers he want. So let us say user enters a value and which is stored into n here. Okay, so it is now into n. Suppose the number of terms entered by the user is 5. Assume like that n is equal to 5. And then printf even natural numbers are, we are trying to display the even natural numbers. Initially count is 1, while c is less than or equal to 1. So definitely it is 1 less than or equal to 5. So it goes inside. If I percentile 2 is equal to 0, initially I is declared as 1. It is initialized as 1. So 1 percentile 2 is equal to 0. No. If this satisfies, it means it is even natural number. Otherwise, it is odd natural number. We are checking this condition. If this is satisfied, then we will display it and we calculate this sum. Then increment the count by 1 because one value is already taken. Okay. So this is how it is done. If I percentile 2 is not equal to 0, then it is not an even natural number. Therefore, we simply move to the next number, I plus plus, by incrementing I. So this loop repeats until the count becomes 5. That means we display 5 natural numbers which are even, and then we calculate the sum of those natural numbers using this sum is equal to sum plus 9. Okay, so once this loop is completed, it means that count became 5. That means 5 even natural numbers were displayed and summed up. Okay. Then after completion of the loop, we display the message sum of even natural numbers is percentile d comma sum. Okay, and then return 0. So just like in the previous program 3.3, I have shown you how to traverse the program using the corresponding variables and how the values of variables updates when the program executes. So please practice this program just like we did it with the 3.3. Okay. This is 4.1, which calculates the sum of even natural numbers, n natural numbers. This is 4.2 to display the n terms of harmonic series. We know that harmonic series is 1 plus 1 by 2 plus 1 by 3 plus so on up to 1 by n terms. Okay, and the result also the program is asking. So we first need to know, to solve this, we first need to know what is the range, that is a n value we need to know. Okay, so it is calculated here. N value will be given by the user. So we store the value of n into this after asking the user as enter range. Then we display the series. Series is I is equal to 1, I less than or equal to n, I plus plus, printf 1 by percentile d comma I. Because I starts with 1. In first iteration, I value is 1. That is 1 by 1 will be displayed. In second iteration, it displays 1 by 2. In third iteration, it displays 1 by 3, and so on. Like this up to the given n terms, because the condition is I less than or equals to n. So it displays all the terms starting with 1 by 1 up to 1 by n. Okay, and we need this plus symbol only for the values before the last term. After last term, that is 1 by n, we don't need that plus. That is the reason why I'm using a condition here. If I is less than n, that is the terms before nth term, then only display this plus symbol to combine those values. Okay, to represent it as a series. Right. Otherwise, you don't require this plus symbol. Right. And then I'm updating the sum value also parallelly. Sum is equal to sum plus float of 1 by I, or else in place of this float typecasting, if you feel it difficult, you can simply write it as 1.0 by I also. Okay, so you can replace this float, you can remove this float and you can write it as 1.0 by I. Okay, either way you can write it. So once the loop is completed, the sum gets displayed, that is the series gets displayed, and the sum is calculated. Once the sum is available, just display the sum. After the loop, printf sum of series is percentile f comma sum. With this, the series and the sum gets displayed. Okay. So here is a sample example given. Enter range 5, and then it displays 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5, and also shows the sum of these given terms as 2.283334. So you can check the value once again whether it is correct or not. Okay. So this is 4.2. And the third program we already practiced in our classroom session also. This is to check whether a given number is Armstrong number. So we know the definition of Armstrong number, that Armstrong number is a number in which the sum of cubes of individual digits in the number is equal to the original number. Okay. So I repeat the definition. A number is said to be Armstrong number if the sum of cubes of individual digits of the number is equal to the original number. Okay. So we're going to check this with the help of program now. So initially, we will ask the user to enter any number. Actually, it is asking here for 3-digit number, but that's not true. You can use any number. Enter any number and then store it into n here. Okay. So number is now given by the user, copied into num. And because we require this original number also, so just copy this value into another temporary variable. Okay, so now these two, num and original num, contains the same value. I don't want to change this original number, therefore I will make use of a temporary number for performing the operation. And the loop goes like this. If original number is not equals to 0, you need to calculate the remainder by using original number percentile 10. This returns a digit, a single digit from the last. That means if the number is given as 328, if you divide it by 10, okay, what will be the value here? After dividing, it returns 8. The remainder is going to be 8 because we divide it by 32. It goes into 32. 10 32s are 320, and the remainder is 8. So if you divide any number with 10 and take the remainder using percentile operation, it gives you the last digit of the number. Okay, so it is always going to produce the last digit. Therefore, this remainder stores the last digit of the original number. And then the result is initialized to 0 at the beginning. Result is equal to result plus remainder into remainder into remainder. That means we are using 8 cube. The first digit is 8. It will calculate 8 into 8 into 8, which is assigned to result. Okay, result is equal to result plus 8 into 8 into 8. Now result will be updated. And again, you are calculating original number y is equal to 10. This is equal to, this statement is a shorthand assignment statement, which is used for writing original number, something like this, original number is equal to original number. Okay, instead of writing that thing, I'll write ON plus, it's not plus actually, original number is equal to, it is division. Original number is equal to original number by 10. Instead of writing like this, original number is equal to original number by 10. This is a division operation by 10. You can write like this in shorthand notation. Original number by is equal to 10. Okay. So this, what happens is, this takes the, if you divide any number with 10, it produces the quotient, that is the remaining number after retrieving this last digit. So it returns 32 now, and then it goes back. Now the original number contains 32. Again, it is saying 32 not equal to 0. Again, it calculates the next digit that will be displayed as 2. It calculates 2 into 2 into 2, which will be added to result, and it goes on like this until the original number becomes 0. Okay. So when the original number becomes 0, it comes out of the loop and checks if the result is same as the number given by the user, because this stores the original number given by the user. It is still there. This only this value is modified, but this still contains the value entered by the user. So if the result, which is sum of cubes of individual digits, is same as the original number, then we can say that the given number is an Armstrong number. Otherwise, we'll say that it is not an Armstrong number. Okay. This we already practiced in our classroom session. Just go through that example. If you want to write the same code in our classroom session, you can use it. So suppose if the number given is 371, it displays that 371 is an Armstrong number, since 3 cube plus 7 cube plus 1 cube is going to be 371. Okay, so this is 4.3. Right. So that's enough for today. We have discussed about 4 exercises. All of you, please practice these exercises either using Turbo C editor or use some online C compilers. In Google, you can type online C compilers, and there will be several such results you will get. You can use any online C compiler to test your program execution. Okay. So all of you practice these programs, and then write down your observation books and records. Okay, so that's all for today. Thank you all for your patient listening. See you in the next class.